Bismillahirrahmanirrahim. Allahumma salli ala Sayyidina wa Maulana Muhammadin wa ala alihi wa sallim. Allahumma rabbi zidni ilma. Allahumma rabbana atina fid dunya hasanatan wa fil akhirati hasanatan wa qina azaban nar. Ameen. Allahumma salli ala Sayyidina wa Maulana Muhammadin wa ala alihi wa sallim. Alhamdulillahi rabbil alameen. In this lecture, I will solve P3 of March 2022. Well, all these instructions are very important, especially this last one. Give non-exact numerical answers correct to 3 significant figures, or 1 decimal place for angles in degrees, unless a different level of accuracy is specified in the question. Here are some important tips to solve the paper in a good way. Avoid careless mistakes, avoid shortcuts, read the questions carefully. Here are some examples of exact and non-exact answers. Under root 2 is an exact answer. 4 pi by 3 is also an exact answer. This 1.125 number is exact because of this last digit 5, because we can convert this number into fractional form. So this number is exact. So leave this answer as it is. All fractions are exact answers. We can write 22 upon 7 as 3 whole 1 upon 7. Well, sine 0.5, sine inverse 0.5 is exactly 30 degrees. So this answer is exact. So leave this answer as it is. And don't write this answer as 30.0. This will be wrong. ln 3 is exact. E power 5 is also an exact answer. Non-exact answers. This answer is non-exact because we cannot convert this number into fractional form. So we have to give this number up to 3 significant figure. So when we will round this 9, we will get 13.5, and this number is up to 3 significant figures. This answer is also non-exact, and these two zeros are non-exact. This number is up to 5 significant figures. 1, 2, 3, 4, 5. Because when number starts with zeros, then zeros are non-significant. Now we have to round this 8 to give this answer up to 3 significant figures. So when we will round this 8 here, we'll get 220. And these 3 zeros are as it is. So this number is 3 significant. This 0 is significant. This angle is non-exact. So we have to give this answer up to 1 decimal place. Therefore, this number will be 30.0 when we will round this 7 here. Well, you can find the link of the math website Math by Sir Qadri in the description, where you can find the soft copy of this lecture. We should learn and spread knowledge. Question number 1. Solve the inequality. In order to solve this inequality, we have to remove both the modulus. And for that, we need to square on both sides. And make sure you square this 3 as well. When you will expand this expansion, you will get 4x square plus 12x plus 9, and here you will get x square plus 4x plus 4. When you will bring all these terms on left hand side of this inequality, you will get minus 9x square, 12x minus 36x plus 9 and minus 36. When we will simplify this, we'll get minus 5x square minus 24x minus 27. You all know when we take negative sign common, then we always change the sign of inequality. Now we have to break the middle term. 27 times 5 makes 135 and 9 times 15 makes 135. So the factors are 15x plus 9x. By taking the 5x common from these two terms, we have x plus 3, and 9 common from these two we have x plus 3. So finally we have x plus 3 and 5x plus 9. Because of this lesser sign, write the answer in this form. A smaller number is here and larger number is here. Well, there is no need to check the answer. Both the answers are fine because modulus is on both sides. So when modulus are on both sides, then there is no need to check the answers. Both answers are always right. Question number 2. Well, on a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities. This means circle with center at minus 2 plus 3i. Center must be inside the bracket and this sign must be negative. And the second inequality is y is equal to minus x. The line of argument z is y is equal to minus x. 3 pi by 4 means minus x. Now we have to sketch both on a same Argand diagram. So circle with center at so this is the circle of radius 2 and this circle should be here because center of the circle is at minus 2 and 3, minus 2 plus 3i. This is 3 and this is negative 2. This is 1 and this is negative 1. Always take same scale on both the axes. This is the imaginary axis and this is the real axis. Now the second locus is y is equal to minus x. 3 pi by 4 means y is equal to minus x. So this is y is equal to minus x. This angle is 3 pi by 4. Now we have to shade the required region. This means we have to shade inside the circle. And this means we have to, the angle of z is less than or equal to 135 or 3 pi by 4. So we have to shade this side. So the common region is this. This is the common region. Make sure you must label imaginary axis and real axis, both the axes. Next question, number 3, linear law. So we have 2 points, an equation, and we need the values of the unknown constants c and n. So number 1, we have to rearrange this equation. We have to express this equation into this form, mx plus c. For that we need to take ln on both sides because we have ln on both the axes. So x power n y square is equal to c. So by taking ln on both sides, we have ln x power n y square ln c. By using product law here, we have ln x power n ln y square ln c. By using power law, we have this equation. Now we have to make ln y the subject. So we'll get minus n ln x ln c. Finally, we have minus n upon 2 ln x plus ln c over 2. You can call this as equation number 1. So this is the first step. Whenever equation is given, try to convert the equation into this form, y is equal to mx plus c. Now with the help of these 2 points, we will find gradient and c of this line. So number 1, gradient, y2 minus y1, x2 minus x1. So gradient is 1.21 minus 0.91 over 0.31 minus 1.06. So this answer is negative 0.4. For c, always use this equation, y is equal to mx plus c, and substitute gradient and any point into this equation. So 1.21, gradient is negative 0.4, x is 0.31. I'm using this point. You can use either this point as well. Therefore, the value of c is 1.334. Now, make the equation of the line by using this equation, y is equal to mx plus c. This is known as linear law. So y is ln y. This is capital Y and this is capital X. So ln y, gradient is negative 0.4, x is ln x, and c is 1.334. call this equation as 2. Now you have to compare these two equations for the values of n and c. So by comparing 1 and 2, we have minus n upon 2 is negative 0.4. So n is 0.8. See, I compared the coefficient of ln x of both the equations. This is minus n upon 2 and this is minus 0.4. And I got n, 0.8. Now I will compare these two for the value of c. So ln c over 2 is 1.334. So when you will multiply 1.334 by 2, you will get 2.668. You know the base of ln is e, so c is e power 2.668, which is 14.41. Up to 2 decimal places. It is according to the requirement of the question. See, find the value of n and the value of c up to 2 decimal places. So this is 14.41. Question number 4. We have to prove dy upon dx. And these are parametric equations. To prove gradient from parametric equations, we first differentiate both x and y with respect to theta. So differential of 1 is 0 and differential of minus cos is sine. Now we have to differentiate y with respect to theta. The differential of positive cos is negative sine. Minus 1 upon 4 is copied. Cos 2 theta will become minus sine 2 theta, and the differential of 2 theta is 2. Now we have to use this formula of gradient. Dy upon dx is dy upon d theta over dx upon d theta. Therefore, dy upon d theta is negative sine theta. When we will simplify these two and these two negative signs, then we'll get half sine 2 theta. And sine theta is dx upon d theta. Now we have to use double angle formula here. So according to double angle formula of sine, we can write sine 2 theta as 2 sine theta cos theta. Now we have to take sine theta common from numerator. So when we will take minus sine theta or just sine theta common, you can also take minus sine theta common. Then we will have 1, these two will be cancelled, 1 minus cos theta. Divided by sine theta. So finally we have 1 minus cos theta, and negative sign is outside the bracket. Since we have to prove this answer, half angle and sine, so we have to use double angle formula of cos here. As we know, sine square theta is 1 minus cos 2 theta upon 2. We have done this in trigonometry. Sine square 1 theta is 1 minus cos 2 theta upon 2. I'm sorry. Now we have to write this formula for angle 1. Because we have cos 1 theta here. So 1 minus cos 1 theta will be sine square half theta. See, 1 is here and 2 is here. So this relation is twice. This angle is twice of this angle. Or this angle is half of this angle. So when we have 2 here, then we must have 1 here. Similarly, if we have 1 here, then we must have the half of 1 here. So it's half theta. Now bring this 2 on left hand side. So 2 sine square half theta is 1 minus cos theta. Now substitute the result of 1 minus cos theta, this result here. Therefore, gradient is minus 2 sine square half theta. And this is what we had to show. We had to show this result. Well, this is the most important part of this question, the double angle formula. Number 5. Well, we have to find the values of alpha and beta. So by solving these two equations simultaneously, we can find the values of alpha and beta. Number 1, we have to expand these two with the help of sum of angle of tan. So it should be tan alpha plus tan beta over 1 minus tan alpha tan beta. This is the sum of angle formula of tan. Now we have to substitute tan alpha here, and the value of tan alpha is 3 tan beta here and here. So we have 3 tan beta 1 minus 3 tan beta times tan beta is equal to 2. So in numerator we have 4 tan beta, and we can cross multiply this whole thing here. So 1 minus 3 tan square beta. By simplifying this equation and rearranging this equation, we will get this thing, 6 tan square beta plus 4 tan beta minus 2. By taking 2 common, we have 3 tan square beta, 2 tan beta minus 1. By breaking the middle term, we have 3 tan square beta, 3 tan beta, minus tan beta minus 1. By taking common, we have 3 tan beta plus 1 from these two terms and minus 1 from these two. We have tan beta plus 1. Finally, we have tan beta 1 upon 3 or tan beta minus 1. So beta is this is in first quadrant. According to this domain, we can work in first and second quadrants. So when we will take the inverse of tan 1 upon 3, we'll get 18.4. And this is in second quadrant. So the basic angle is 45. Tan inverse 1 is 45. Therefore, beta is 135. This is 45 and this is 135. Now we need alpha. Tan alpha is 3 tan beta. So first we are substituting tan beta 1 upon 3. So 1. This is in first quadrant. So the answer is 45. Tan inverse 1 is 45. Tan alpha 3 tan beta. And the value of tan beta is minus 1. So tan alpha is 3 times minus 1. So this is in second quadrant. We need basic angle. Tan inverse positive 3. Whenever we find basic angle, we ignore negative sign. So tan inverse 3 is 71.6. This is 71.6. So the answer is 108.4. Up to 1 decimal place. Hence, the final answers are alpha 45 and beta is 18.4. And alpha is 108.4 and beta is 135. These are the final answers. Next question, number